Well, let's begin a new chapter. We're going to learn about equations, inequalities, and problem solving. So for our first lesson, we're going to learn about linear equations in one variable. These are our objectives for this lesson. So you'll need to put those in your notes. And then there's our vocabulary. An algebraic equation is a statement that two expressions have equal value. So it's just setting one expression equal to another expression, and that will make an equation. Solving algebraic equations involves finding values for a variable that make the equation true. So a solution to an equation will make it true. That's why you can go back and check your answers, check your solution, plug it back into or substitute it in for the variable, and then you'll find out if it makes your equation true. A linear equation in one variable can be written in the form ax plus b equals c, where a is not equal to 0. So notice there's only one variable, an x or a t or an m, whatever, but there's only one variable in the problem. Equivalent equations are equations with the same solutions in the form of the variable equals the number or the number equals the variable. So we'll look at what that's talking about here later in the lesson. There are properties of equality for addition and multiplication. You'll find this on page 48 in your textbook. It also would be helpful to place this in your notes. For example, we're given the equation 8 plus z is equal to negative 8. So we're needing to solve for the variable z. The problem is it has an 8 added to it. So what we need to do is add a negative 8, or since this is a positive 8, we're going to subtract 8 from both sides. The addition property of equality says that if we're adding the same thing to both sides, it's going to keep the equation equal. So 8 minus 8, this zeroes out, and a negative 8 plus a negative 8 is a negative 16. So when we simplify, z is equal to negative 16. Let's look at another example. Notice we've got some like terms. Like terms are on the same side of the equal sign. Here we've got two different terms with a p in it. Here we have two different constants. So the first thing we need to do is simplify by combining our like terms. 4p minus p is 3p, and that leaves our negative 11. 2p is by itself over here, but negative 20 plus 2 is negative 18. So the first thing you do is combine your like terms. Don't move these across. You can, but it just takes more time. Simplify your equation. Let's subtract 2p from both sides. We're going to simplify. So we're going to put the p's together. This is a positive 2, so we're going to subtract 2 from both sides, or 2p. That is going to leave us with p minus 11 equals 18. Now let's isolate the p. This is a negative 11, so let's add 11 to both sides. This will leave us with p is equal to, and negative 18 plus 11 is negative 7. Now it's very easy to check your answer. You can go back in and substitute in a negative 7 for your p's. And if you get the same answer on both sides, then you know it's a solution to your problem. There's no reason why you should not know if you have the right answer to an equation, because all you have to do is go back in and check your solution. Look at another example. We've got some parentheses, so we need to start by using the distributive property. 5 times 3 is 15. 5 times z is positive 5z. Now this is a negative 1. There's no number out here, but that's understood to be a 1. So negative 1 times 8z is negative 8z. Negative 1 times a positive 9 gives you negative 9. Be very careful. This is so easy to say negative 8z and then write plus 9. Don't forget that negative 1 has to be distributed across both numbers. Now we've got some like terms that we need to combine, so we're going to simplify our left side. 5z minus 8z is a negative 3z, and 15 minus 9 is a positive 6. Now let's get our variables together. A lot of people like to keep all the variables on the left side, so I like to work with a positive, but it doesn't matter. You're going to get the same answer either way. So here we're moving the variable to the left side. This is a negative 4z, so we're going to add 4z to both sides. Now let's isolate the z by subtracting 6 from both sides. So z is going to be equal to negative 6. Look at another example. Oh dear, these don't look like the others. We've got fractions. So how do we go about solving for x? We've got 1/7 that's being multiplied by x. So let's just multiply both sides by the reciprocal. The reciprocal of 1/7 is 7/1. Because we want to get this just to be x, we need this to equal 1. Well, the multiplication identity, we want it to equal 1, so we multiply by 7/1. Whatever we do to one side, we've got to do to the other. So x is equal to 35/9. This is another one, but we don't have fractions on both sides, but still, by the same token, let's multiply by the reciprocal. What is the reciprocal of 3/8? Why, it is 8/3. 6 times 8, 48, divided by 3 is going to give us 16 when we simplify both sides. Recall that multiplying by a number is the equivalent to dividing by its reciprocal. Whenever you divide by a fraction, you're in essence actually multiplying by its reciprocal. That's what it's saying. Let's solve for z. Well, we've got something added or subtracted from it, so let's add 1 to both sides. We'll have 3z is equal to 27. What I've noticed are a lot of common errors. This is a positive 3z. They try to subtract 3 from both sides, but no, this is being multiplied. You want to use the inverse operation. 3 is being multiplied by z, so let's divide both sides by 3. So z is equal to 9. Go back and check your solution. Is 3 times 9 minus 1 equal 26? Is 27 minus 1 equal 26? Why, yes it is. Okay, we've got some like terms we need to simplify first. Like terms, remember, are just simplified on the same side of the equal sign. 12x plus 8x, 20. 30 minus 6 is a positive 24. Now let's start isolating the variable. We need to get rid of this 24 first by subtracting 24 from both sides. Whatever you do to one side of the equation, if you do the same thing to the other, it keeps the equations equal. That's going to leave us with 20x minus 14. Remember, you do not subtract 20 because this is being multiplied. Let's divide both sides by 20 and then simplify. Both of these are divisible by 2, so our answer is negative 7/10. Solving linear equations in one variable, you will find this information on page 51 of your text in a lavender chart. Make sure you have this in your notes. These are the steps to go about solving. Okay, let's look at an example. We're starting to get more complicated now. We need to, first of all, get rid of this fraction. We hate fractions, don't we? I don't, but a lot of people do. They don't feel comfortable with them. But if we multiply by 5/1, we're going to get rid of this fraction. Whatever you do to one side, you do to the other. Then we distribute. 3y plus 9 equals 10y plus 30. So we distribute the 3 across this parentheses and the 5 across this one. Looking at it, there are no like terms, so we're ready to start simplifying. This one's working like I like to do it. I like to keep my largest coefficient is positive, so I'm going to subtract 3y from both sides. So I'm going to end up with 7y. Now let's move this 30 over. So we're going to subtract 30 from both sides. So we have negative 21 is equal to 7y. Again, we divide both sides by 7. This has got the y on the right side, but that's okay because I like working with a positive coefficient with my variable because I make less mistakes. I know my weaknesses. Everyone's different. You can work this, if you would like, by subtracting 10y from both sides and then moving all the constants over to the right. Either way is fine. You're going to get the same answer. Where do we start here? Well, there's that parentheses. Let's get rid of it. Let's distribute the 2 across the parentheses, so 2x plus 2. Do we have any like terms? Well, on this side of the equal sign, we do. 2x plus 3x is 5x, and negative 7 plus 2 is negative 5. Look at this. Both sides of the equation are identical. So since the equation will be true, it doesn't matter what you put in for x, both of these will always be true. The solution to this is all real numbers. So your answer isn't going to be x equals 2 or x equals 5 or like negative 7/10. The answer to this one is going to be all real numbers because these are identical. Where do we start here? Distributing 3 across the parentheses, very good. There's no like terms, so let's start solving for x. So let's subtract 3x from both sides. Look what happens. We end up with negative 7 is equal to 3. Is negative 7 equal to 3? No, never, not in my world. So since there's no value for the variable x that you can substitute into this equation that's going to make that equation true, this one has no solution. Okay, very good. You're ready to begin working on your assignment.